Okay, so example 1 in 3-10 is directions are asking us to solve if necessary, because the first one's not necessary, and graph the solution set on a number line. So when we're talking about a number line, we mean one of those horizontal number lines, as you can see. Oh, darn it. I didn't mean to do that. Oh, that's devastating. Okay, whatever. Anyways, not important. Focus. So looking at this example 1 here, the thing here that you want to realize and you want to look at, and I'm going to put a big star by this, and you need to be very careful with the, we'll say order / placement of the variable. And what we mean by that is, or what I mean by that is, if you look at this example 1 here, this says that 3 is less than or equal to x. Now, typically when we solve an equation, we like the x to be on the left-hand side. So let's make a note of that also. Typically, we want x to be on the left-hand side. So that, it's okay if it's not, you just have to be careful when you're graphing it. So if I were to rewrite this, this clearly says that 3 is less than or equal to x, which means that x compared to 3 isn't going to be less than, because that would be not possible. If 3 is less than or equal to x, that means x is greater than or equal to 3. Notice how that inequality kind of flipped there when you moved the placement of the x. So I'm just going to make a note here that these are the same thing. These are the same. So when we're graphing this, the number that we find the inequality to be, the number that we get when we're done isolating the x, is what goes in the middle of our number line. And then I can go back to my chart here. It is an or equal to, so it gets that filled in circle. And then don't forget to shade. So let me get a green big star here that says don't forget to shade. And what we mean by shade is for a number smaller, we get 2. Which way are the solutions? If that's saying that x is greater than or equal to 3, well, do the numbers get greater than or equal to 3 to the right of the number line or to the left? And that would be to the right. So we are going to go ahead and just shade that way with our big giant arrow. That was a little excessive. It really doesn't need to be that ridiculous. But there we go. So that shows us that every single number from 3 onward, hence the arrow showing that it goes on forever, that all of those numbers would make this inequality true. All of those numbers are greater than or equal to 3. So that's how we show that infinite number of solutions.